So, good morning, everybody, and welcome to all of the students. If you are joining, finished officially the Unit 3. So, now what we're going to do is this week we're going to start with the Unit 4. And so, if you could grab your Chapter 4 or Unit 4 combining things examples booklet. So what I'm going to do is I'm going to get started on that with lesson number 1 on functions, combining functions. Um, so in this unit, we should be able to sketch the graph of functions that are the sum, product, difference, product, or quotient of two functions. Okay. Write the equations of the function that are the sum, difference, product, or quotient of the other function technology. Evaluate a composition of function. Determine the explicit equation, and determining the domain and range of the composite functions, including restrictions. So then jump ahead with lesson 1, combining functions graphically. It's on live right now, so it's either sum, add or subtract, multiply, or divide some functions. And we're going to do that using the graphical method first. So jumping into example number 1, f of x and g of x are shown of these two functions, y equals to f of x plus g of x. So f of x is a function on together. And then what kind of graph are we going to will result from that? So let's start off with the f of x. We're going to try to accomplish this using a table of values for now. So x, and then we have points that's already highlighted in here. We have 4 points. So you're looking at 0, 2. Okay, so that point is 0 for x, and f of x is 2. The next point is this point right here. When x is 3, f of 3 is f3, the value of the function when x is 3 is 3. Okay, we're looking at this here, f of x, the function. Now this point right there, when x is 6, f of x is 4. So that means if x is 6, y is 4. So 6, 4. And last but not the least, this one here, the point there is 9, 5. So x is 9, y is 5. Okay. So that's our f of x function. 0, 2. This point would be 6, 4. Let me use my pen. I'm going to highlight this as my red. So this particular point would be when you have a function, that's the 2, 0, 2. So this is the x, f of x. This one is 9, 5. Okay, this line going down. Okay. So in this particular case, this point is 0, 6. Coordinate of that point is 0, 6. This point here is 3. So what we're gonna do, we're actually using the same x values in here. In here, we're gonna write down the g of x. So if x is 0, when x is 0, g of 3 is 4. So 4. When the g of 6 is 2. So this is going to be just an x 0. Particular case, we have this x and f of x, then x with the g of x. Now I think we're ready to perform this combine x, g of x. F of x plus g of x. F of x plus g of x. So f of x is 2 plus g of x is 6. So 2 plus 6 will give us 8. F of x is 3 plus g of x is 4. We're getting a 7. Plus a 6. And then 5. Okay? So we have all these organized. What we can do is we can sketch the graph of these two. Okay? So I'm going to use a different color pen so that to kind of highlight that for a second. So we're going to plot the point 0, 8. So 0, 8. And then the next one would be 7. Next one is 6. For x is 6, y is 6. And then last but not the least, 9, 5. When x is 9, y would be 5. So you can see we're slowly seeing the pattern. So let's graph that. Okay. So I'm just going to use some kind of a straight edge to graph that. So equals f of x plus g of x. Okay. So that's a first example. Take a look at example number 2. Example number 2 says the graph of h of x and j of x are shown. H of x is here, and j of x is here. It says here, word difference means subtracting the two functions. So creating a table of values to organize our thoughts and our work. So starting off with, start off with the h of x. The ones that are really, really nice if we can. And so this point in here, I'm going to try to do that again with the red one. 0, 20. This point is 40, 40. 40, 40. And then the last point there is 80, 100. 80, 100. Okay. those are the coordinates in this function h of x. So let's go ahead and put in. So 0, when x is 0, h of x, h of 0 is 20. So 0, so x and h of x, 80, comma, 30. So let's put that in. J of x. So 0, 10, 40, 20. And then 80, 30. 80, 30. We have 3 nice points there. Now we could do the subtracting of these two functions. So subtracting those two functions is h of x. So h of x minus j of x. So h of x is 20. J of x is 10. So 20 minus 10, that's 10. 40 minus. Now we're going to turn our focus on x and h of x minus j of x. So this is going to be our x, and then this one will be our y value to put it on a graph. So let's do that. So the very first one is 0, 10. 0, 10. So that's 40, 20. So 20 right there. And then 80, and then 70. 80 and 70. Okay. So now our graph kind of goes like go up. Okay. So this is the graph. The green one is the graph of y equals h of x minus j of x. So we have that new graph there. Okay. Go to example number 3. So in the previous 2 examples, we did the sum and difference of functions. What we're going to do this time is we're going to do the product of 2 functions. So what does a product mean? So the word product means the answer to a multiplication graph of f of x and g of x. F of x is this nice parabola over here. And the g of x is a square root function, and it looks like it's inverted down. It's reflected and shifted up. So we're not really worrying about that one right now. What we're trying to do is we're trying to figure out the product of these 2 functions. Okay, plenty of room for us to do the work in here. Do that. First, we're gonna focus on the f of x. I don't see a lot of, like, they don't give us all of the nice points in here compared to the other one. So what we need to do is we have to search for those nice points. So this is a nice point there, 0, 0. 1, 1 is a nice point on a function. -2, 4 is a nice point on our function. And then this is a -3, +9 is a nice point on our function. Okay. And on the other side, and this one here is a 339. Okay. So let's see if we could figure out a good point that matches the two. Now looking at this one over here, we have these two, this one. For one, it's really a nice, we can approximate that one. Okay. So oops, we should be consistent and do red. So x, f of x. So I can still do my thing. So go -3. If it's x is -3, y is 9. If I have -2 is +4. That's that point right there. If it's -1 is +1. X is 0. F of x is 0. Going on to the other side, it's going to be 1, 1, 2, 4, 3, and 9. And of course, there are a number of points. There's infinitely number of points in this particular graph, but those are the nice ones that we can actually read. Now let's go ahead and take a look at this graph over here, the g of x. Okay, so it says here, this point here, 0, 2. Okay. Now, what about this part over here? X is -3. The g of x, we don't have any. This is not defined. Right? It's undefined. What about when x is -2 for g of x? Well, there's no graph going to the -2, so that also is undefined. -1, there's no graph. -1 is, this is also undefined. So the x value starts, for g of x, starts at 0, 2. And then this one here, we can approximate that one if we wanted to. And then this 2, when x is 2, y is 0. And when x is 3, it's approximately, we can approximate that. We can say it's about 1.5. Okay. And same thing with this one here. So this is approximately 0.6. We can say about 0.6 approximately. And then when x is 2, so that's 2, 0. When x is actually negative 0.5. Negative f of x times g of x. So 9 times something undefined would be undefined. We can't multiply something. Times 2 is 2. 1 times 0.6 is 0.6. 4 times 0 is negative 4.5. So what does the graph look like, those two? So the very first one is 0, 2. So 0, 2 right there. Okay, made a mistake again. See here, f of x. So 0 times 2 is 0. 1 times that is 0 is 0.6. 4 times that is 0, 4.5. Okay, start again. So 0 times 0 is 0. 1 and 0.6. 1 and 0.6, so somewhere there. And then 2 and 0. 2 and 0. So again, f of x times g of x, so if negative 0.5 is negative 4.5. So the result would be this one right here. F of x okay. Next part there is, what are the domains? The domains of f of x and g of x, and the domain of f of x times g of x. So let's start with the domain. Domain of f of x, because this is the quadratic function, that's going to be from negative in the domain of g of x. And then, well, what happens to the domain of f of x times g of x? So let's just take a look here. For f of x, the domain is from negative infinity to positive infinity. For g of x, it's going to be from 0 to infinity. So anything over here. As you can see that anything below 0, that's undefined. We have nothing to multiply from f of x and g of x. So the domain of f of x times g of x is just from, also from 0 infinity. So the domain of f of x to g of x times g of x is from 0 to infinity. So that's the only thing that we are asked for, is the f of x times g of x function and its domain. So now let's take a look at example 4, last but not the least. So example number 4, we have graph of h of x and j of x that are shown. So this absolute value function right here. And the j of x is the parabola function right there. So on the same grid, sketch the graph of the quotient. So the word quotient means the division, the solution, or the answer question. So this is, we're dividing the two functions. So let's go ahead and do that right there. Do the exact same thing. The absolute value of x, h of x, is the absolute value function. Let's go like this so I don't get confused between. This is the absolute value. H of x is the absolute value. And then the j of x is the parabola. J of x is the parabola. I can write it like this, or I'm writing it this way too. So it doesn't matter. Okay, let's take a look at this h of x first. H of x. This absolute value function, there are some nice points. This is a 0, 0, 1, 1. This is really nice. Lots of nice points. Okay, so what we could do is we could use some of the nice points over here. So it's from -6, +6, -5, +5, 4, +4, -3, +3, -2, +2, -1, 1, 0, 0. Okay, so there are a lot of nice points there. The parabola over here, parabola. So here we have values for -6, but it's all the way down, but we can't see it. Okay, so let's just pick some points that are really nice. 1, 8, 0, and then 3, 0. So let's put those values in. So when x is negative, it's just that we couldn't figure it out from the graph. What else? -2 is +5. So when x is -2, y is +5. When x is -1, y is 8. Gotta line them up. When x is -1, y is 8. And then 0, y is 9, so 0, 9. When x is 1, 1 is 8. When x is 2, 2 is +5. And when x is 3, 3 is 0. Now, we do have the value for it, but it's going to be some negative value. So we'll just, this is going to be some negative values this way. Okay, so what we're going to, h of x divided by j of x. So h of x divided by j of x. So 3 line solutions, so undefined. And 2 divided by 5, so 2 divided by 5. That one is we can certainly answer that one. That's equal to 0.4. 8 is 0.125. So 0 divided by 9 is 0. And then let's take a look again. 1 divided by 8, that's another 0.125. And then 2 divided by 5, that's going to give us 0.4 again. And before, with a rational function, the denominator can't be 0. When the denominator is 0, okay, there is asymptote. There is an asymptote. So because this is undefined at 0, then that means there's going to be an asymptote at -3. So there's an asymptote at -3. So that's our asymptote. And here's our other asymptote. Okay, so we have those two asymptotes this way. Now, what's the other thing that we, because this is a rational function, looks like a rational function, I know I'm kind of getting ahead of myself in here, but we have 2 vertical asymptote in here. We also will see a horizontal asymptote around here as well. Okay, so let's figure that out first. Let's graph some points and we'll go on from there. So if if x is negative 2, so we're going to focus on x and the last column. So when x is negative 2, the 2 is going to be positive 0.4. When it's negative 1, it's going to give us 0.125, so 0.125. When x is 0, it will just go like this. Increases so fast. Okay. So this part here will increase that way. And as it gets closer and closer to asymptote, this graph here, now what happens over here? What happens over here? So the absolute value of x here increases, and then this one becomes a negative. So what happens, let's just pick some points in this side over here. When x is negative 4, when x is negative, it's going to go down. And then this function looks like. So h of absolute value of x compared to the numerator. And because of that, it approaches the degree, right? This is degree 1, and then this is degree 2. You have a greater degree in the denominator compared to the one in the numerator. So that means so that means the horizontal asymptote is at y equals 2. We learned before, we talked about the rational function. So that graph will approach the horizontal asymptote as it gets bigger and bigger. Now, what's the domain? What's the domain of this function? H of x, everything is possible, right? For h of x, the domain is infinity, right? So that includes a 0. And the j of x, same thing. It's the parabola, so the domain is from negative infinity to positive infinity. The only thing that's not defined in here, the things that are not allowed, is when the j of x is going to be 0. So the domain write it down here, of h of x divided by j of x use that will accept, with the exception when j of x is equal to 0. The domain of h of x divided by j of x when j of x is equals to 0. And where is j of x 0? So where is j of x equal to negative 3 and positive 3. Okay, so to put that into perspective, so the domain, therefore, domain of h of x divided by j of x is equal to negative infinity up to 3 to negative 3 union from negative 3 positive infinity. Or we can say x cannot x plus or minus 3. Okay, so it could be any value. Examples of adding functions, subtracting functions, multiplying functions, and dividing functions. So what I'm going to do is I'm going to assign some questions in here, and no, it takes a practice. So give those questions a try. Highly recommend them. It's from your workbook, questions 1 to 3. If ever you get stuck, or if you have any math at work email, yeah, only if you get stuck, or if you have any questions whatsoever for math. That's about it. I'm gonna end the lesson here. So thank you again for your patience. Thank you for your participation, and thank you for watching this video.